We're going to try to do a dual setup thing where you'll be able to see us through my computer and Zach will share his screen so that you can see slides.
Perfect. Aztec Warriors!
We're going to take the Aztec theme as far as we can take it. We will have a lot of Aztec names.
I'm really excited about this today because I want to figure out how to get Aztec running on the burner wallet so I can do private transactions.
That would be so cool. Yeah, you should. I mean, it should be relatively straightforward. I say that. Yeah, who knows? It will.
Word. So could I deploy the Aztec contract to XDAI? Because it's a separate chain.
It's a separate chain, but presume. So sorry, pardon my ignorance, but XDAI just still runs on the EVM.
Exactly. Yeah, it's like an exact copy of Ethereum.
Yeah, then absolutely. The only thing, like the only EVM related chain that Aztec can't run on is Ethereum Classic.
Okay. Just cool.
Yeah, just doesn't have some of the elliptic curve cryptography stuff that we need. So there's a presentation before us, yes? We're talking about works on Plasma first, right?
Yeah. So Alex Lasov is on Meet right now. Wait, there we go.
No, I'm not. I'm here. Just muting when I'm not checking.
Hey, Alex, nice to meet you.
Thanks for being on, by the way, Alex. I know it's later on your end. We're working on getting a more sort of manageable time for Europe in the coming weeks. So hopefully will be resolved in the future.
Oh, okay, no problem.
I think it's actually quite nice. It's just hit 10 p.m. In London, and it gave us an excuse to eat bad food and stay at the office late. So.
Cool. Austin, is it okay if are you able to handle the recording just since I'm on mobile?
Yeah, I should be able to. You want me just to? Let's see. When do you usually start recording?
Now is good. I mean, like, what we'll do is like we can always edit it after the fact. So if we just start now, that's great. Just because on my end, on mobile, I won't be able to see. I won't be able to see whether it's a recording.
Okay.
Icon.
Let me go shill it on Twitter real quick, and then I will hit record. Is that cool?
Cool.
Hi, man.
And Scott,
I'm going to mute here until Zach joins. You won't hear us.
Scott, I have the live stream link working if anybody wants to retweet that or create their own live stream link. So that's live now, and that link in the chat.
Awesome. I'll retweet that.
So it's the dudes from Aztec and Alex talking about ZK Snarks on Plasma. Is that right? Whoa,
So
feedback.
Well, yeah, that wasn't me, I don't think. But if it was, let me know.
Yeah, sorry about that. OBS. Hang on.
Yeah, that was sorry about that, guys.
All good. So Alex, can I'll let you guys both do intros before we get started. And I'll just Austin, let me know when the recording starts.
Okay, yeah, I'll just do that now. Okay, recording is starting now. I have to request meeting host.
Oh shoot. Yeah, okay, that's let me do that.
Okay, cool.
There's a separate screen on.
There we go. I'm a co-host. Okay, now I'm hitting record. Record on this computer, right? I'll just save it and send it to you. All right, it's happening.
I would.
Oh. Wait,
yeah,
wait.
that's fine. That's good. Both are good options. I'm gonna make everyone a co-host. I mean, the.
Okay, we're recording. Gitcoin live stream.
Awesome. So while I go and make these people co-host, yeah, today we have sort of two ZK Snarks related presentations, which is pretty cool. So the first is from Peter, actually, who's here too, and Alex Vaslov from the Matter team. And they're working on a ZK Snarks implementation, a plasma implementation story using ZK Snarks. And I guess technically that's called a rollup. I'd be very interested to know more about even why that distinction is made, because currently my knowledge is limited on that area. But um, let's get started by just having maybe um, let's say Alex, if you want to just give a brief description of sort of your project, and then we'll let the Aztec guys sort of give a brief overview of theirs, and then we can sort of jump into the two presentations.
Yeah, sure. Unfortunately, we don't have any formal presentation material. We try to do our best to actually put it into our first and the only Medium blog post. So I think the link was somewhere. In principle, what we're working on is a transaction aggregation solution using ZK Snarks, which proves every block validity, which allows you to use the balance model instead of UTXO model. And in addition, first of all, this is not Plasma. It was what Alec told in his Twitter, and it was what we emphasized in our blog post. This is not Plasma because we use a different data availability model. We post some data on chain, very small portion, but it's enough in principle. So every user in worst case scenario, and all these transaction aggregation solutions should really work even in a worst case scenario. So even if the system dies and you know only the latest, uh, let's say root hash or the block header, no matter how you call it, you can restore the tree of the balances and just exit. So you can take your funds out from the system just using one smart contract call on Ethereum without any cooperation from the single operator or multiple operators, which could potentially uh, just support the system. What ZK Snarks give us basically two things. One is an ability to prove the block validity, which is very powerful. And this is the reason why we can use the balance model. A second one is we can hide a lot of data in private witness, as every ZK Snark allows. And this in principle allows us to save a lot on the data which we have to publish somewhere. For example, we don't need to publish signatures at all. We just need to check the validity of the signature inside the Snark. And then if we can prove the validity of the Snark itself, then very good, because we most likely observed the proper signature, or we were able to successfully forge it. The same way as you can steal someone's private key. Um, so basically, that's it. Um, in general, the construction follows what Vitalik has proposed on his research, with different implementation details. The main idea is the same. What we would like to bring in the system ourselves is some degree of privacy, which is quite difficult there. Just for now, most likely not going to happen. But yeah, we just want to make it working public and ideally usable in real life, no matter would it be the Ethereum transfers or let's say DAI transfers or a payment system. It's quite powerful technology as it is. Uh, and it really needs an application. And first of all, it will demonstrate that public blockchains are not the dead end. It actually shines in a public blockchain when you don't need permissions, and where the consensus is quite expensive, and the execution is expensive, and the storage is expensive. Because basically what we do is we compress roughly 16 million balances to just one miracle root, which is just one storage slot on Ethereum, which is, I would say, quite effective compression.
Awesome. So yeah, we'll jump. There's a lot to unpack there. Let's jump into letting Aztec just do a quick intro, and then let's dive back into those ideas.
Yeah, so just addition to the Alex speech, the technical speech, like in general about the use cases of this project. The first of all is like Dexes, so we can solve the scalability things that Dexes need now. And another thing that also the developers can think about is like how to integrate with the stable coins, and we can work with the like global payment system to improve speed and cost of transactions in main Ethereum network with the different kind of coins, especially with the stable coins. So it's just for just a brief discuss how it works. Yeah.
Awesome. And Tom Arno, who wants to take it from the aspect side?
Yeah, so I'll just give a brief overview. We have a small presentation planned, well, prepared, which kind of just gives a bit of a dive into what the asset critical is, what it enables, and also some of what we feel are the kind of the problems in the current, like with current technology solutions for how to actually get workable, meaningful private transactions on public blockchains in a way which is general purpose. Oh, sorry. Sorry, a bit of microphone feedback. In a way that's general purpose enough that you can developers can create confidential digital assets that have reasonably complicated transaction semantics, but are compatible enough that they can all communicate with one another in zero knowledge, so that you can actually start to do, instead of unilateral value transfers in zero knowledge, you can actually start to do confidential settlements and start to build zero knowledge dApps on top of Ethereum.
Do you want to give a brief overview of what ASIC is for people that might not have heard of us?
Sorry. Yes. I'm sorry. It's been the end of a long week. Aztec is a protocol that enables private transactions on Ethereum by using some reasonably unique zero-knowledge cryptography. What it allows you to do is convert some kind of public value, public ERC20 token, into a confidential note, an encrypted representation of value, where nobody can see how much you earn, and you can then send this encrypted value around to other people, to yourself, in a very similar way to how Bitcoin X2 objects are transacted, except nobody can see inside these notes. Nobody can see what's in them, but the blockchain can still validate the mathematical legitimacy of these transactions through our zero-knowledge protocol. And that's what we do.
Very cool. Cool. So just by sort of roll the dice, we'll have Peter and Alex just dive in a bit more on what they were talking about with their not plasma implementation. Very important to note, but very cool regardless. So I'll let you guys maybe talk a bit more about it in detail. Some of the pieces that came up that were really interesting to me were around implementations or use cases for DEXs and so forth. But as much detail as you can sort of go into on the product and sort of like the implementation, the details that you're really focused on, the better. So I'll let you guys take it away on that.
Yeah, I would say Peter can start and kind of the product. Let's say product, which we would like to see as an application of the technology itself, and maybe with some more or less real impact. And then I can more or less tell you a story how we actually went to this area and how it works, and that there is quite a lot of room actually for contributions. Right now, a lot of work which I cannot handle myself. So let the Peter start, and I will continue.
Yeah, thanks, Alex. Yeah, generally speaking, we are looking for good collaborations with other developers. I don't know in person like all of you guys, but there is a lot of use cases for Plasma, as I see, like DEX, the general payments, integration with the stable coins, for example, the gaming, what is also like CryptoKitties. If we put all the CryptoKitties inside the Plasma, it will not stack the whole Ethereum network. So we have a bunch of things to do with these projects, like yes, and it's also the zk snarks, the cryptographic stuff, and also it's like high level API for integration, how to put the transaction inside the Plasma, and how to integrate it with the D apps. So we are looking for developers who are interested in to participate in these projects, and also in other big companies that interesting to integrate the scale solution to their protocols. So feel free to ask me a question directly, and yes, this is a general idea of why we are here and what we want from the community. And
What's a good way for developers to get started using your stuff? Is there a certain place they should go and look? Is there some documentation, or what's the best method for a new developer to get started?
yeah, for now, we have our description of our protocol. It's on our GitHub, and there is a like schedule what we want to do in the near future. And yes, I will send you a link, and then we will open the whole protocol. Probably Alex will explain better about the schedule of development.
Great, thank you.
Yeah,
Alex?
well, in principle, yeah, we have an internal plan for development of the system itself. Right now, it's plagued with we need to make a decision what features we want to put in the first version because uh, because we really try to tackle privacy and have some form of confidential transactions. First, actually hiding the amounts only, not the senders and receivers, just amounts only. It's quite difficult, and we're not sure that we want to put it in the first version. But as soon as we're done with features, it should not take a lot. Uh, Basically, like the very basic description of how it should work can be found on Vitalik's post on his research, which calls things like on-chain transaction aggregation for 500 transactions per second. On our side, we based our work on a Bellman library from a Zcash, which was originally not compatible with Ethereum due to the use of the different curve. So what we have first to do, kind of the preparation step, is to implement all cryptographic primitives required for Ethereum curve in a compatible way, described as a well, first of all, Bellman made by the Sean Bow is just a best piece of software which I ever seen, and I always say this. This is literally the best piece of software. So what we had to do is basically had to extend it. Um, First, in the sense that it can make the proofs on a specific curve, which is compatible for Ethereum. Then there was a part which is quite close to the gadget library of the LibSnark. So this was a set of higher level primitives which allows you to do basic operations like hashing inside the snark. We had to a little bit extend it too and make it a little bit more generic and compatible with the new curve and principles the primitives which we want to use. It's still very far from the current state of the gadget library for LibSnark, and this is the first part where people can try to make the contributions. Uh, for example, right now it has only very basic operations like SHA 256 hash, uh, and it has a Peterson hash, basically just work, basically some primitives to work with the numbers and bit decompositions. There is a lot of work there which can be done. For example, the permutation networks for memory accesses, maybe the shuffle proofs which are also usable in some examples. For example, in gaming, shuffle proof is a very powerful tool, so you can in principle write a game using zk snarks uh, with some actually public source of randomness and the public source of provable randomness. And there is a shuffle proofs are very important. In principle, I would say everything which is in the gadget library for LibSnark, ideally you want to see it there. It's just a matter of time which you need actually to put to extend it. One of the good parts of Bellman is it's very much more convenient to work with the LibSnark. I have written gadgets in LibSnark before, and there is very confusing part, especially for beginners, where you need first to declare all the variables of the gadget, and you need to construct all the constraints for a gadget, and then in a separate function you need to construct all the witness. Uh, those are, let's say, highly technical terms, uh, but the fact that you have those in three different places is quite confusing, especially when you try to work the logic of your program from the beginning to the end. You really want to write linear code. In a leap snark, you had to write it in almost two different places. This is where Isabellman actually shines and allows much more convenient work. And I think it will be much easier for people to start work with it. Unfortunately, there are no good examples there. There is no good description how you should actually use the function, design the gadget. There are a lot of comments in the codes, but the live description, but like the real descriptions, how you should structure and like the what would should be a coding style for this, because there are quite mm, some details. Like not every function is evaluated in place. Some of those evaluated lazily, and I really hit this problem myself when I found the mistake in a debug mode. Everything worked. In a release version, it didn't, just because some functions were evaluated lazily. So I was getting nils in some places, but this is all the details. I would say even writing some description of this piece of software, the Bellman itself plus the gadget library which we support, would be a great first contribution. It's actually very important. For now, there is no intermediate language. Like for right now, there is no Socrates equivalent for the Belmont library, and I don't know if it will happen anytime soon when someone will make one. Uh, but so people would have to write the gadgets from the lowest level primitives, and even just having some good example and the README would be great. Unfortunately, I still don't have any time to just write a set of articles how to really use it. We agreed that somewhere in the something like 13th of February, I would do the live demo how you can actually start with the Bellman, just actually live coding demo how to code the basic circuit. We will choose some problem. It would be for at Con 2019. Uh, I don't have any links for this, but should happen somewhere. I think it can be found on the internet. A preliminary, it would be somewhere around 13th of February, and there it would be probably the best start for developers to actually try to use it. But unfortunately, the entry bar for ZK Snarks is quite high. And yeah, I'm talking a lot. So really, really, and ideally, if there are any direct questions, most likely would be much easier if I can just answer them directly.
Alex, I sent your Bellman implementation link to the chat. Probably you can just follow with some related links for somebody who want to understand it more. Can you provide some like getting started things? What else people can read in more human readable way rather than just the code that you build? So what is the
No,
best?
this is actually the most difficult problem right now, as we built a lot of code and with the good comments inside the code. With the one problem, we don't have the good demo how you should actually start. Just there are some pieces of code in a like in a form of tests which potentially show you how you can construct the simplest gadget, but there is no good human readable description yet. And I don't know if it will happen anytime really soon. This is the problem. Right now, we're quite focused on the trusted setup ceremony, and this is separate problem for Ethereum trusted setups. That for let's say we would like to do the trusted setup for every snark on BN 256 curve and make this trusted setup reusable up to some point. And there it would involve a huge amounts of data, huge amounts of computation, and all of this should be ran on normal laptop. So right now, this is the main focus. How we can provide the solution for people to make something like 50 gigabytes of data for a trusted setup in multi-party computation, and still do it on their personal laptop with, let's say, 8 gigabytes of memory. Uh, for now, this is our main priority, and this is another part where people can participate and participate in a trusted setup as soon as this will be announced. It will not be for us, it will be for all the Syrian community, but this is also a good contribution. Just participate in a trusted setup because all previous trusted setup contributions, no one was happy with how it works. Let's make the first one which will actually work and make everyone happy.
Yeah, I think we
Alex,
will
sorry.
have to create a common group like about the trusted setups, so people can get updates about how the processes works. And Alex, um, yeah, I think it's better to announce that are you can I meet with the Ethereum that you will do the workshop on 13th of February about the snarks by conference?
We more or less agreed about the schedule. I mean, we agreed that I would do it. I don't know if it was put somewhere publicly and announced, but in
Mhm.
principle, it's on my schedule.
I think it will be a great starting point for everyone. So Alex will show how to work with the snarks in live demo,
Alex,
I believe.
sorry, sorry to interrupt, but I just what you just said was extremely relevant to what we're doing actually, because we also are performing like putting together a multi-party computation protocol for Aztec's trusted setup, and I believe there's an extremely high amount of overlap between what the elliptic curve parameters that we both need. So I think it'd be great if I'll ping you offline because it would be good to have a conversation about what you need for your trusted setup and whether it gels with what we're trying to do. We could collaborate.
Yeah, sure. Well, in principle, uh, I'm not that familiar with. I mean, I've read the Aztec paper, but I don't remember what parts. I mean, what are the what is the toxic waste and what parts you need for a for a trusted setup. Uh, in
I think
yeah, but we can definitely discuss it in person. We base our work in a Zcash trusted setup with just an important difference that we have to find a way how it to work this trusted setup by parts, so we can fit everything in memory.
yes, yeah, I think from what I read about the powers of Tau ceremony, it's very similar to what we need, which is effectively a various number of group elements, which are all like polynomial sequences, g to the x, g to the x squared, g to the x cubed, on and on it goes. I believe that's like kind of part one of the powers of Tau ceremony. I might be wrong about that though, but yeah,
No, for powers of Tau, this is basically it. You just need uh, to put the generator in different consecutive powers of some toxic waste. So that's why it's trusted setup for in the public ceremony.
yeah, that's
For
exactly.
yeah, for Ziki Snark, it's actually quite trivial at this part. But yeah, I'm just not sure what part is required for Aztec trusted setup.
That's literally the only part that's required. But it's so the kind of the step one for the Zcash not trusted zone ceremony is what we need to achieve. Although I suspect we need a lot, like the powers we go to are significantly that range is significantly greater than what you would normally need for a snark circuit. But yeah, I think there's a lot. Yeah, let's chat offline about this because I think it's yeah, I think it'd just be cool to get involved in what you're doing with your trusted setup.
Oh yeah, yeah, sure. I will send a link actually on our current work in a trusted setup. Let me just post it in the chat.
So just as like I mean like what's really interesting here is that like there is that overlap to me. And so one thing to maybe talk about is just like what are those core pieces like when you're talking about in the context of where you're doing like multi-party computation and like those trusted setups, like what are the sort of key challenges like at a you sort of described them in the context of what you're just working on. But what are the key challenges maybe like dumbed down people like me that aren't just like familiar with this particular part of the ecosystem like that you guys need in order for this to be like really sustainable and successful?
Well, first of all, there is well, it's two-sided. One is the technical part. The trusted setup, as was described, is actually quite trivial ceremony. Each participant, one after another, contributes his private entropy to the public accumulator. Uh, the problem is that this public accumulator would have something like 250 million elements, each element is from 64 from 32 to 64 bytes, so it makes quite a lot of data, which should be created. So it requires some computational power. For example, on my laptop, it would run for something like 20 hours. The second part is it requires quite a lot. Well, in original implementation, which was done purely in memory, it would require something like 50 gigabytes of RAM on your PC. Um, it basically, in principle, people would be able to run it on some ABS machine, but for a trusted setup, you want to run it on your local hardware. So this part had been rewritten to be able to work by parts and fit in just something like 1 to 4 gigabytes of RAM, depending on your settings which you want to use. So this is a technical part. There is organizational part, which is also difficult because it would require people to run for 20 hours on their more or less standard laptop, let's say 24 hours. And in addition to download and upload something like 75 gigabytes of data, this is difficult on organizational part. It's every so every participant should be effective. So show up in time, download the piece of data which he or she need to download, make the contribution and upload the resulting piece, and ideally just have something like, let's say, 3 days for it for each participant. And so the, the ceremony shouldn't run for infinite amount of time. So it should be a set of participants which really should show up in time, share, like, use the computational resources, ideally do it on some personal device, so the entropy stays in memory and which can be destroyed after it. So this is purely organizational difficulties that will that we also expect to encounter. I mean, when I say we, is uh, it's not only us as a Metro team who want to do some trusted stuff. Guys from Gnosis want to do it. Guys from Circum, from Socrates, we all participate to actually make it happen. And the powers of Tao is the beauty of this ceremony is it allows you to do a huge to produce a huge amount of entropy, which can actually be later reused by any zk snark circuit. In principle, this is the powers of Tau is only the first step of the trusted setup itself. Uh, so, and this part is circuit agnostic. So you can reuse it for any zk snark circuit which you produce later. You will need to do the much simpler trusted setup just for a particular circuit. This trusted setup will run for a much smaller amount of time and will require a much smaller amount of resources. So the organization would be much easier. But this first part is just an enormous piece of data which should be communicated and computational power. So it can be run and should be run once and just reused by as many people as possible. That's why it should run ideally flawlessly. So it would be people who can be trusted and who can show up in time, who can do their contribution, and then ideally verifies that their contribution is included. So all this just breaks down to technical and organizational parts. They're solvable, definitely. It just will require some work.
Awesome. So with that, I'll open up the floor to like any questions. But one thing I think actually might be even better is Aztec, if you guys go ahead with the presentation, just given that there's a lot of overlap, I think it'd be interesting to like have both of you guys talk more about what you're doing after that. And maybe then we can get like around questions about sort of this general ecosystem after that. So unless anyone else has any particular questions, Aztec, take it away.
Cool, thanks a lot. So yeah, I'm here with Anna and Paul, and I've got just a small presentation about kind of an overview of the ASIC protocol and some of the problems we're trying to tackle in the blockchain space with regards to private transactions. So I'm I'm a bit of a not good with technology and just sharing my screen. Just a second. Yeah. Okay. So.
Can everyone see the screen?
Yep.
Yeah. Can you see it? Okay. Nice. So hang on. Let me get rid of this. So yeah, an overview of the ASIC protocol. How to speak in tongues. Effectively, what the ASIC protocol is enabling is private transactions on public blockchains. How can you combine the consensus guarantees of public blockchain but still enjoy kind of the privacy protection that you kind of expect as standards when engaging traditional financial systems? And one of the solutions to this is zero-knowledge cryptography. The ability to prove that you know certain secrets and certain mathematical relationships between secrets without actually exposing what those secrets are. However, there is an enormous gap between what is potentially possible with zero-knowledge cryptography and actually what currently exists, because being able to theoretically construct a zero-knowledge proof system is very different to actually having an actual working application with nice UX. As I think as anybody who's tried to manage handle ZK Snarks is extremely familiar with. And how do we bridge this gap between the technical vision of what's possible and the reality of what actually is there today? And so when it comes to the building blocks for a confidential transactions ecosystem, this is kind of a list I have of what I think is the fundamental pieces that need to come together to enable us to enable private transactions to become mainstream on Ethereum. The first one is customizable confidential transaction semantics. So it's not enough to just be able to transfer value in a private way. So if I have some encrypted, I can transfer some of that encrypted value to somebody else, because that gets you really to Bitcoin. But the key innovation of Ethereum was that by adding a Turing complete virtual machine to the blockchain protocol, it enables developers, app builders, to use Ethereum's semantics to solve their own problems. And you can't do that if you just have a one-size-fits-all solution. So you need a level of customizability, but that can't come at the expense of interoperability. Right now, every single private transaction system that exists on blockchains only works for unilateral transfers. I can transfer Zcash around to somebody, I can transfer Monero, I can use a ZK Snark, or at the moment, Aztec's proof of concept to transfer around like zero-knowledge DAI, but I can't do cross-asset settlements. I can't create a zero-knowledge DApp that will interface with two other zero-knowledge assets and perform some kind of algorithms, some instructions, because none of these zero-knowledge proving systems talk to one another. It also needs these building blocks to be developer friendly. We can't expect developers to be literate in zero-knowledge cryptography or have cryptographic experience because of the enormous barriers to entry that exist when trying to deal with this kind of mathematics, and very high quality off-the-shelf tooling to enable the zero-knowledge proof construction. In the same way that we don't really have to think too hard about how to construct BCDA signatures to send Ethereum transactions. The same should be the same for confidential transactions. And this proof construction and specifically proof verification needs to be efficient. If it's not efficient, then you have massive throughput limitations on an already throughput limited technology. And for proof construction, if there's short proof times, you can't use hardware wallets, and it leads to a not great user experience because you need to reserve lots of RAM, and your proof construction will take minutes or hours, or even you might even require using some distributed parallel computing system like DISC. So with that out of the way, let me just give a little bit of an overview about what Aztec enables, like fundamentally how Aztec transfers value through joint split transactions. First of all, the makeup of an Aztec node is what is an Aztec node? How do you transfer value confidentially on Ethereum? Well, instead of having balances, you have these discrete nodes which act a lot like Bitcoin hucksters, which is in how they work. They're idea is you have some on-chain data linked to a node. You have Ethereum just as the owner. The kind of the Aztec node's public key, the elliptic curve coordinates that represent the encrypted value, and some metadata, which is, can be used by node owners to recover like viewing keys, secret keys, spending keys through secret sharing protocols. And but those notes also contain private data, which is not revealed to the blockchain, which is obviously the value of the note as well as the note's viewing key, so it's decrypted, and the spending key that you need to actually spend it. And these notes can be used in transactions. So this is I always struggle to explain transaction transactions, but Paul had a very good analogy with Bitcoin answers, where effectively notes exist as discrete objects that can be combined together into larger notes, or they can be split apart into output notes that are smaller. And the idea is every transaction has to satisfy a balancing relationship. The sum of the inputs has to equal the sum of the outputs. And because these outputs can have different owners, that's how you transfer value. One extra kind of addition to this kind of these joint-split transaction semantics is the addition of public input and output tokens. So the idea, the ability to take an ERC20 token and convert it into zero-knowledge note, Aztec note form, and similarly to be able to redeem ERC20 tokens out of an Aztec note. But the core, like, fundamental thing that's being verified here is that there's a balancing relationship. If you know that the sum of the inputs equals the sum of the outputs, then the blockchain doesn't need to know anything about what's actually inside those notes, and it can still validate the mathematical legitimacy of these transactions. How actually does this happen under the hood? I mean, how does one create an Aztec node? How does one prove these balancing relationships on encrypted variables? And the protocol really is, the kernel of the protocol is this Aztec commitment function. In the same way that you can have Pedersen commitments and algorithmic commitments, it's the Aztec commitment function is kind of an iteration of the Pedersen commitment, where you can encrypt an integer, but the commitment function itself has a built-in extremely efficient range proof, which I'm happy to go into more detail if people have questions about it. But I don't want to get too lost into the elliptic weeds, because that is a rabbit hole that you can spend several months in, as I found out. But what this enables is the Aztec protocol doesn't use ZK-SNARKs. It actually uses Sigma protocols, which is kind of an older technology and a bit of a kind of the redheaded stepchild of crypto moment, because it's a bit fallen out of favor a little bit. But it enables these Sigma protocols in a very efficient and modular way, and more importantly, enables useful Sigma protocols, because one of the key barriers for this kind of technology has been range proofs. They're expensive, hard to do, but not with the Aztec protocol, not with the Aztec commitment function. They become extremely cheap and easy to perform. So just a little bit of a breakdown of a side-by-side comparison of Sigma protocols and ZK-SNARKs. Because ZK-SNARKs is kind of a technology that is more familiar and a bit more mainstream. Sigma protocols enable to prove algebraic formulae expressed over elliptic curve. And so, you have a relatively basis formula. So, some of the inputs equals some of the outputs. You can validate the correctness of this formula without knowing anything about the inputs. And in the ZK-SNARK world, instead what you do is you represent a kind of a pseudo computer program as a polynomial equation over elliptic curve. So that algebraic formulae that is being validated by the verification algorithm isn't like the raw expression of the mathematics that you're trying to validate. What instead is that polynomial encodes kind of this arithmetic set, these quadratic arithmetic programs. And what you're really proving is that you know inputs that will run this program successfully. So if you have some kind of private transaction semantics or batch batch transactions that accumulate into a Merkle root. ZK-SNARKs are extremely customizable. You can create very complicated semantics with them that are very tailored to individual use cases. Whereas Sigma protocols are relatively simple statements. They're not very expressive, and they're highly custom. The main Aztec, one of the main Aztec proofs is a proof to satisfy this balancing relationship for a set of input and output nets, and that's all it does. It's not general purpose computation. However, a consequence of that is that it is extremely general, because you can use the same Sigma protocols across any confidential asset class, and they can all use the same transaction semantics, which means that they all have a degree of compatibility with one another, which opens the door for complicated settlement mechanisms. ZK stocks generally, each individual use case has complicated semantics, and each individual use case has its own kind of trusted setup process, which limits interoperability. Because if I am building a zero-knowledge dApp that uses ZK Snark technology, and I'm interfacing with zero-knowledge assets that use their own ZK Snark circuits to validate their own transaction semantics, either I have to kind of construct and validate zero-knowledge proofs for every single asset class and every single dApp, or they all have to have some kind of, they all have to trust that the semantics of each program, they all follow a common standard, and that they're all okay with each other's trusted setups, which adds the level of communication complexity. Both are very efficient to verify. Certain protocols are very efficient to construct proofs, which helps for hardware wallets. So without further ado, like, that's kind of the high level setting the scene about what Aztec is trying to do, what we're trying to achieve. And so how we're achieving that is really this piece of smart contract infrastructure we're calling the Aztec cryptography engine. Effectively, it's a smart contract that acts as a validator algorithm for not just one zero-knowledge proof, but a family of zero-knowledge proofs. And so I've got here like a little table of the proofs for our kind of version 1 of the cryptography engine. You have that basic join split transaction, which is what we released in November with our first working confidential transactions on Ethereum. And then in addition to that, we have a bilateral swap proof, so you can transfer value, you can do a trade across 2 different Aztec assets in zero knowledge without exposing anything. And then utility proof, so a dividend proof, where you can prove that one Aztec note is a percentage of another Aztec note, so you can use that for interest rate payments or for calculating dividends. And then on top of that, public range proofs and private range proofs, so you can prove that an Aztec note you have is greater than or less than either a public integer or something that is secret, not visible to anybody, to observers. And you can use those, and you can use those in. It's a relatively small set of proofs, which looks on the surface to not really, they're not very expressive. However, what it enables us is somewhat customizable confidential transaction semantics. In a way, because you can compose these proofs to construct more complicated transactions. So, for example, if I'm creating a zero-knowledge loan or zero-knowledge bond, and I need to, for regulatory reasons, I need to ensure that no one actor has more than 50% of the total holdings of a bond, I can use the range proof from the cryptography engine to check this, and combine that with a joint split transaction or bilateral swap to enact my trades. Similarly, if I have some kind of interest-bearing zero-knowledge asset, I need a way of enabling users of that asset to be able to claim that interest without revealing the value of the holdings. So, if I put $1 million zero-knowledge DAI into a 3% interest contract, obviously the amount of interest I extract has to also be private, but that still needs to be checked against something. So it enables this somewhat customizable confidential transaction semantics, but in a way which is still promotes interoperability, because every Aztec asset and every Aztec zero-knowledge dApp, they listen to the same to one cryptography engine. They validate against the same common set of proofs, and more importantly, the same common reference string. Every single Aztec asset that exists or will ever exist only needs one trusted setup process that will be performed by a multi-party computation, where multiple entities generate their own piece of toxic waste, and as long as one of them destroys that toxic waste, the security of the crypto system is backed by just conventional discrete logarithm assumptions. And exactly like the powers of Tau ceremony, this can scale reasonably linearly to involve a wide range of participants. And that's kind of really the crux of this, is every single Aztec asset, it only needs that one common reference string, which makes it, in theory, hopefully, very easy to build Aztec assets, because you don't need to construct your own zero-knowledge protocols. You don't need to do your own trusted setup. You don't need to understand the core cryptography of how Aztec enables confidential transactions, just in exactly the same way that you don't have to understand the mechanics of how an ECDSA signature works to build a smart contract today. And so the cryptography engine is combined with what we're calling ZK-ERC20, a zero-knowledge confidential token standard. So this is a interface for a confidential token that looks a lot like an ERC20 token. The idea is instead of a transfer and a transfer from method, you have confidential transfer and confidential transfer from, where instead of public instructions, you're sending zero knowledge proof data and like a zero knowledge proof ID, which corresponds to a proof in the Aztec cryptography engine. And this is really how we can. This is the kind of the vehicle by which you can create some somewhat customizable confidential transaction semantics while still enjoying cross-asset interoperability. In exactly the same way as an ERC20 token works. And so what we're trying to do at Aztec is really creating this ecosystem of zero knowledge dApps. And something else which is extremely important is that this ecosystem is extremely efficient. It's efficient to verify these proofs because they can all share zero knowledge proofs that are relevant to the use case. For example, in this little diagram, if there's a zero knowledge dApp like it's a centralized exchange that's confidential, it receives a proof, a transaction from some external source, and it validates that against the cryptography engine. If that proof proves multiple balancing relationships between different asset classes, for example, the bilateral swap zero knowledge proof proves a balancing relationship between two different Aztec assets, the cryptography engine will verify this proof, record it, and then return instructions to the zero knowledge dApp, which it can then broadcast to the relevant zero knowledge assets. And these assets, in turn, when they query the cryptography engine to attest to the validity of their instructions, the cryptography engine does not need to perform any additional computation, doesn't need to verify any additional zero knowledge proofs. And so, to give an example, for a bilateral swap, if you had a decentralized confidential exchange and two confidential Aztec assets, and you wanted to engage in that bilateral swap where every one of those assets had to validate their own zero knowledge proof, then that transaction would cost about 3 million gas, but using the cryptography engine and sharing that one proof, it only costs about 600 to 700,000 gas. So this is something that we've been putting together for a while. Really excited to talk about, and really excited. And this is today actually we published a couple of VIPs that describe this cryptography engine and these zero knowledge token standards. And so yeah, link them there. Feel free to have a read. Absolutely love your comments and any thoughts and questions that you have on them. So yeah, how do you play around this? How do you get involved? Because what we're trying to do as Aztec is enable other people to give them the tooling that they need to build their own, to implement solutions for their own use cases. The reason why Aztec exists in the first place is because we were trying to build a syndicated loan platform on Ethereum, and we needed private and they weren't there. And so we think that what this does range is far wider than any one loan application, which is why we view our mandate as is one to enable the Ethereum developer community to be able to construct their own private assets and their own private transaction semantics. And so you can find all the latest up-to-date smart contracts and tooling at our Aztec monorepo, which there's a link in the slide. So we currently have, I think there's 3 packages. There's our JavaScript pre-construction library, our smart contracts, and a little demo repository, which is the demo that we used to broadcast confidential transactions onto Ethereum in November in the form of zero knowledge DAI. And so that kind of serves as a base template for how to start to work with confidential transactions. And yeah, feel free to have a root around. And as always, we would love comments or feedback about how people want to use this kind of ecosystem and what they need from the tooling if it's not there. And finally, just a little thing I want to talk about, because this has been a labor of love and madness of mine for the last 6 months, which is something that we've been foiled by is the extreme cost of verifying zero knowledge proofs, because there's just the raw volume of cryptography that you need to perform is quite a lot. You need to perform these elliptic curve scalar multiplications, and there's just pre-compiled smart contracts inside Ethereum that performs algorithms for you. So if you call a smart contract at address 6, what will actually happen is the get or parity node will actually perform elliptic curve scalar multiplication for you, but for an outrageously high, not outrageously high, but a very high fee, 40,000 gas, which is, considering the bare cost of an Ethereum transaction is 21,000 gas, like storing data is 20,000 gas, adding 2 numbers together is 3 gas. So these are very expensive. And in an effort to kind of decrease the gas costs of verifying zero knowledge proofs, and this is also something which is actually applicable to Gitcoin as well. So it'd be great the short bias trust curve that is the same as the form as Akash one in the Beacon files. It is a smart contract, but it is more efficient in terms of gas than the Beacon files. Up to between 30 and 50% more gas efficient, depending on how many points you need to multiply, because it performs multiple scalar multiplication. So the more points you need to multiply together, the more efficient this thing becomes. And we estimated it'll probably reduce the verification gas costs of the ASIC protocol by about 20%, which is, well, it's very welcome. And if this is useful for other people, it's all open source, all licensed under LJPL. We also developed our own domain-specific smart contract programming language to get this done, called Huff. There's a story behind that, but I'll leave that. But yeah, that's also in our repository. So feel free to have a look. So just, I know I'm being this is going on for a while. So the final slide is, what is the roadmap for Aztec? So what we're calling our Tenochtitlan release, in the spirit of Ethereum's release names. Effectively, what we want our MVP cryptography engine deployed to testnets and in a state where developers can actually start building dApps and assets which use it, with expectation that the interface isn't going to change, that everything is going to be the same moving forward. As well as releasing our complete asset proof construction API, so instead of split transactions, you also have bilateral swaps, interest payments, different computations, escrow accounts, range proofs, that kind of stuff. And that actually validating that bistrial smart contract and doing more rigorous testing. Q2, we wanted to finish our trusted setup multi-party computation protocol, so that because right now the trusted setup we use, I just generated it on my laptop, it's proof of concept. It's not really something we would recommend to be used in prime time, because whilst I am, I like to think that I am a trustworthy individual, and I did destroy the toxic waste. I didn't even view it, but I cannot prove that to you. So what we really want to do this trusted setup multi-party computation, so that you can actually get involved yourself in the trusted setup and therefore guarantee its correctness. As well as very much like to formally verify the ASIC smart contracts in the cryptography engine, because the cryptography engine, it validates zero-knowledge proofs. It needs to work. It needs to not have any bugs in it whatsoever. And so I think if there is ever a reason to formally verify smart contract, it is that. So that is on our roadmap. And then the plan is in Q3 to actually have a production-ready mainnet release where we can claim with absolute confidence this is ready to use. The cryptography is sound and secure. There are no bugs. You are not going to lose your assets. And combine that with implementations of zero-knowledge wallets and other Aztec integrations into common and popular services to kind of light the way about how to develop confidential private assets. So yeah, that's it. Thank you very much. It's been a pleasure to present that to you all, and we would be very happy to answer any questions that you have.
So I just got to start off by saying, speaking of your last 6 months of madness, looking at these contracts, they are insane, man. There's a lot of assembly.
Thank you. Yeah, it's been a bit of a discussion of mine.
That's awesome. So so first of all, I didn't know what toxic waste was, but then I knew what it is now by the context you just explained. It's basically the stuff that's left over from the ZK ceremony that you need to trash so stuff doesn't leak. Is that right?
Precisely. Yeah. If you know what the toxic waste is, I mean, it varies depending on the snark circuit what the consequences are. But for us, what it enables you to do is if you know the toxic waste, you can prove a range proof of any integer, which means you can double spend. It means you can create notes of arbitrary value in the ASIC system. It is not something that is acceptable to us. So this is why we very much want to engage in this multi-party protocol and get as many people as we can involved.
So assuming though that toxic waste, that I trust that you deleted that toxic waste, you did deploy this stuff to mainnet and move some transactions around like a couple months ago now, isn't it? So technically it is live on the mainnet. It's just not audited to the level that you would like it to be. Is that right?
Absolutely. Yes. And we've also the interface of our more modern contracts is more advanced and more general purpose. So that's kind of the one thing that's changing is as shown in the IPs. If you compare the the interface of that token standard to the Aztec ERC20 bridge.sol contract. I think some things have changed. But yes, we did deploy to mainnet last year.
But follow up on that. So with the Fluidity engine, you're gonna have like much more modular, proofs. What's being deployed in November is just for an Aztec ERC20 bridge, and it's kind of like constrained to that use case. But in Q2 and Q3 this year, we're gonna release more stuff.
Yeah.
Awesome. Thanks, guys. Yeah. So at a high level, just so I understand this, basically you bridge an ERC20 into the Aztec contract, and then you use that value and you exchange a bunch of notes, and these notes can be zero value and they can be to all sorts of random people, and no one knows what's actually going on in the notes. And then eventually you bridge it back out to the ERC20. Is that kind of conceptually close to what this is?
Yeah, so you have two kinds of Aztec assets. You have the public to private assets. So the DAI contract is one where you take public ERC20s, you basically give the Aztec bridge contract ownership of those ERC20s, and in exchange that bridge contract gives you zero knowledge nodes that you can trade around. But then you can also basically deploy full zero knowledge assets. So the first three implementations of Aztec, the people that are working on it now, they're all going to be like fully private assets. So they issue basically a smart contract which has a register of Aztec nodes that asset is always going to transact in private.
So it's kind of like cash on Ethereum, but with stable coins
and other things.
That's the dream.
Hopefully, yeah. I mean,
just to like be completely transparent, because we're not trying to claim something we're not. The difference between Zcash and Aztec is a confidential transaction system, which means you don't know how much of something you're transferring, but you do know if I issue a confidential transaction in zero knowledge DAI, people can know that my address owns a zero knowledge DAI note. It could be zero, and that address could be a stealth address, but people do know that. Whereas in Zcash, the entire transaction graph is obscure.
Perfect. Okay.
So that's something
so you bridge your you bridge your DAI in, and then you get notes back, and then you can break those notes up like UTXO and send them to a whole bunch of people, and people can see that you sent them to other people, but you can't see the value. So you could have a ton of zero values, and they can be over and over and over again. Those notes can be moved around, and then eventually someone would take their note that has value and bridge it back out.
Yeah, although I mean, ideally, Aztec eventually gets to a point where you never have to bridge it back out. So
Sure.
you get to the point where, but yeah, that's the gist. We are thinking, correct me if I'm wrong, that we're not advanced with this at all, but like that initial bridge from public to private is something that we want to. We basically want to obscure the link between the public addresses and who owns the private nodes.
Yes. I have a sorry. I have a kind of a mixed zero knowledge proof that will do that, but it's like super experimental and not really something that I can say with any confidence works. It's just something kind of just it's just a little proof in my notebook that I've not had the time to. Oh, there's been lots to build, but that might be coming in later down the line.
One important observation I would add here is that the more users you have in your Aztec contract, the better and the more privacy you have. So if you only have like one user, if you deposit DAI and you just like spend that DAI around, it's obvious like for everyone that like you still own the same amount. But if you get like 10 users, 100 and so forth, it starts to get like harder for everybody else to just know how much everybody owns.
Yeah, precisely. So what we're planning on doing as soon as we have our crypto rendering release, creating kind of Aztec canonical versions of popular digital assets today, like creating the zero knowledge form, because the more people using the same asset, the greater the privacy. Just to answer Dave, the PowerPoint is we haven't uploaded it, but I'll do that immediately after the presentation. We'll shove it on our mono repo.
Yeah, I have two, let's say, highly technical questions. First of all, do you have any plan to support not just confidential transactions, but the idea of confidential assets? So when you can basically hide the amount and the asset type at the same time. And the second one, if Ethereum improvement proposal for reducing the price of the precompiles is going to be accepted, wouldn't be bulletproof based range proofs and similar protocol be cheaper than the one is based on Aztec? Because at the end of the day, Aztec needs a pairing equation to check, and pairing cost is not going to be reduced a lot, while the scalar point multiplication is going to be reduced 15 to 20 fold.
Yes. So to answer this, I guess the first one, have we attempted to think about like hiding the asset as well as the values? That is not something that we've that's really on our roadmap. It's in order to do that, you end up creating effectively like something that looks much more like a mixer, which while obviously that's incredibly useful, that's something that SIK Snark is much more suited for, and that comes at the cost of not being able to create like zero knowledge dApps that can transact in confidential assets, because you don't know what the confidential asset is anymore. So yeah, that's not something that's on the roadmap. With regards to the precompile reductions, yes, we're actually incredibly excited for the precompiles to gas cost be reduced, and from my computations, it's not. I mean, Aztec is still going to be substantially cheaper than bulletproofs because of the fact that we just use so very few scalar multiplications. We use, like an Aztec joint split transaction uses about 13 scalar multiplications, and a bulletproof proof size is logarithmic with the proof statement. You still need the verification algorithm still needs to perform scalar multiplications that scale linearly with the cardinality of the range of your range proof. So if 32-bit range proof, then I believe you need at least 64, and then there's scalar multiplications plus about like 5 for the kind of stuff you take on the end. And then because even the precompilers aren't going to do, they don't support they don't enable like Shamir's trick to batch multiplications together. That means 64 cores for the precompile per note, whereas an Aztec asset you need 3 per note. So even though we do need a pairing check, the gas costs are still like significantly less. And something to add, the Aztec protocol it needs precisely one pairing check, regardless of the number of assets that you're transacting in a given transaction.
Oh, yeah, okay, thanks.
Awesome. Yeah, that is enough of these highly technical questions. Let me ask some more dumb ones. So what's the difference between a mixer and the Aztec smart contract? Like, it seems like it does a very similar thing, but maybe I don't know enough about mixers.
Yeah. So a mixer is it's a way of effectively you put something into the mixer, and then you can then later pull something else, and you completely sever the link between the inputs and the outputs. So like for example, like you could imagine take like an Ethereum mixer where you can deposit units of 1 Ethereum into the mixer, and then later in a different address can then pull out 1 Ethereum, and you will know you don't have a link between the two addresses. It's a way of breaking the transaction graph. In the Aztec protocol, the transaction graph is not broken; it's very visible because you can see, like when I put tokens into an Aztec node and then start issuing joint split transactions, you can see that web of joint split transactions. It's just that you don't know what's inside them. So the value of that graph becomes a lot less meaningless, particularly when you can have nodes with 0. We do enable a mixing like effect by enabling by a stealth address protocol. So we actually on top of Aztec, you can use Monero's stealth address protocol to create seemingly random looking addresses that nobody can link to an identity, but you as the identity holder will know will know what they are, which is a little bit different to like BIP39 derived wallet addresses, because what a stealth address protocol enables is if so Austin, if you had one of these stealth address wallets, I could look at your wallet's public key, I could derive an Ethereum account for you that only you need to spend the private key to send something to that account, and you would be able to identify that you own that account. I would, but nobody else would. And so you can use that combined with the ASIC system to like layer on anonymity and get the effects of a mixer. to give an example, you put 50 DAI into a zero knowledge into an ASIC note form. You issue a bunch of joint split transactions. At the end of it, you have a 50 DAI note, but you can't really link it to the original one, and then some random looking address then pulls that 50 DAI out. One of the problems with mixing, well, problems with using that in the ASIC protocol is it's more of a fundamental Ethereum critical level problem, which is you need gas to broadcast transactions, and that gas is the Ethereum for that gas is public, so it's much harder to break the transaction graph of funding accounts than it is to actually break the transaction graph for like the higher level transactions on Ethereum.
Awesome. Yeah, thank you. That's a good explanation. One other thing I was wondering about is like message signing with the notes. So once you're in and you want to move notes around, it would be really cool if it was built in where you could send those with signed messages and have like a kind of like a meta transaction relayer. So basically the person who owned the note wouldn't have to have Ethereum. They could just sign a message that says send this set of notes to these set of people, and then like a relayer somewhere else could submit that and pay the gas for them. That would be like a pretty powerful thing to add to that.
That's exactly the plan. Actually, if you look at the ZK ERC20 interface, the transaction sender is completely divorced from the economic beneficiaries of that transaction. So, and everything like the legitimacy of that transaction is validated by two things. One is obviously the zero knowledge ASIC proof, but the other is ECDSA signatures signed by the kind of the stakeholders, the ASIC node owners. And all of that is completely divorced from the transactions, the actual transaction issuer.
That's very cool.
Thank you.
Anybody else have any questions? I feel like I'm kind of capitalizing the questions right now. Sounds like no. Shoot them to chat if you have any other questions. I don't know if Scott is here. Scott, are you here? We might.
Hey, yeah.
Oh yeah. Okay.
I really liked the flow of the conversation there, so I didn't want to interrupt. But on my end, I mean, this is fantastic. I guess one thing that you sort of went over in the roadmap part at the end there is just, I guess one thing that would be good to get clarity on is, like, what do you think the timeline is for those changes to be made such that like you would actively want people to be using this in production? When do you think that'll be ready?
Well, we're earmarking early Q3. Although to be honest, that was under the assumption we'd have to write our own trusted setup algorithms from scratch. So sorry, this has been a very fascinating conversation, particularly with Peter and Alex have been working on. So that actually might speed up our timelines quite considerably. But yeah, at the very least Q3. We're being deliberately cautious because we basically just want to go through an extremely thorough auditing and validation process of our spot contracts. So our spot contracts are going to be like functionally ready a long time before that. So if you're a developer looking to build a zero knowledge you'll be able to a long time before that start working on it, experimenting with testnets. But we do just want to pump the brakes a bit on our production ready release just so that we can completely validate and attest to the security of our contracts.
So to continue that, so if you are a developer and you'd like to deploy your contracts or you'd like to play around with your contracts and just start like messing around with them and understand how they work, what would be the best place to start? I'm asking for Brent.
But yeah, Monorepo. So we have our pre-construction libraries, our smart contracts, a little demo, demo package which will get transactions to the mainnet that are confidential. It is we do want to create like much more developer-friendly documentation.
I think Paul, you're working on a blog post, like a zero to hero blog post.
Yeah, well, we're working on a bunch of stuff on that, like developing onboarding, and I will handle that over the next week. So stay tuned for that. For like an article on like how to deploy, like from end to end, like a ZK ERC20. Now that it's published, that's much easier to do. But other than that, we plan to like add a ton of packages. We're using Lerna for like to set up the monorepo, and there will be plenty of sub packages added next week. Things like mini packages for contract addresses, so you do not have to deploy yourselves, and so forth. So essentially, at the moment, what you have is like a monorepo with very clear instructions for how to compile and deploy your own contracts. But over the next week, you will have more resources for like how to use already deployed contracts and some articles.
Awesome.
If people start playing around and anything like breaks or isn't clear or you're confused, just ping us on Twitter. We're usually pretty good at responding to Twitter.
I follow Paul closely, so I'll get the rest of you guys in. I'll be bugging him on Twitter for sure.
Always.
Yeah. Easy.
Awesome. So we have like about 15 minutes left, and I know Ivan actually wanted to show off something that he was working on in the community. Ivan, are you still there?
Yep, I'm here.
Awesome. So just before we transition to that, thanks so much, guys, for coming on. Honestly, like I love the work both of you guys are doing. Although I don't really understand it fully on my end, but I definitely want to do a deeper dive into it, and I can sort of imagine some of the more like down the road, really exciting applications of this. So I'm excited to see those start to emerge. And Ivan, so I'll let you take it away for maybe, we have about 15 minutes left on the stream. And yeah, just effectively, I believe it's a sort of Gitcoin Discord integration. Is that right?
Yep. So essentially, I'll share my screen so you guys can see it. How does this work on this? Oof. Start share, is that it? Okay, yeah, okay. So essentially, it's just a simple Gitcoin bot that shows the difficulty, the keywords for the bounty, if they're hiring or not, and then shows a link for that. And then the reward and when it expires. And there's just a whole channel. This is, for those who don't know, this is the Subreddit Crypto Devs Discord. I'm good friends with the people at Subreddit Cryptocurrency, so I kind of started the subreddit and Discord in conjunction with Subreddit Cryptocurrency. And yeah, so there's a lot of developers in here, especially so do you guys. And I have this bot. I used to have it ping Gitcoin every hour, but they've been posting more often now, so I have it set to every 20 minutes now. And we've gotten some of the people from the Discord have signed up to finish these. So yeah, it's been a hit so far. I'm considering adding like a little functionality to tag certain people of skill sets that match the bounty, like let's say Solidity, and it tags all the Solidity developers if they want to. So it can be like optional notifications in a way. But yeah, it works great as like an instant notification for Gitcoin. I'll link the source code to it now in the chat. That's mainly it.
Awesome. So this is sort of relevant for us just because, like, I mean, we're obviously always looking to find more developers to collaborate with us on the platform. That's like my sort of pitch of the day, right? But I really like this as a possible way to do that, and it seems like it's gotten some traction so far. So thanks for sharing that.
Yeah, of course. Do you guys mind if I put the invite link?
Yeah,
For the Discord? Cool. There you go. I know Austin's been messaged a few times by some members to join.
I need to jump in there, huh? I'll do that. I'll do that right now.
Thank you. I appreciate it.
For sure.
No worries if you're busy.
And so usually, like, I mean, what we're sort of diving into now, this is sort of the first piece of that. But like the last, it depends how busy each call is. But like the last 15 minutes or so, we just sort of like try and dive into any questions or like interesting projects that people are working on in the community. And I'd be curious, like, who else here is sort of already working on something, especially like if it's ZK Smarts related, or if there are particular like pieces that are ZK Smarts related. Would love to hear about anything you guys are working on right now. I mean, Austin, I know you're working on stuff, but that's like my default is to ping Austin and ask about what the updates are at this end. Um, that's I'll default to that in a second. But anyone else have any updates for that? Okay, cool. Austin, how are things with the burner?
Yeah, that's basically what the focus has been. You're still sharing your screen there too. It's basically been, yeah, just getting more user testing and getting the thing ready to go, getting the bridge solid. It's weird. Like usually I have like cool new research every week, but not anymore, man. It's all burner wallet these days. But hopefully after ETH Denver, that'll loosen up a little bit more. But I really don't have anything awesome to demo. It's just making it better. I moved the little thumb button closer to where your thumb goes, so it's easier to take a scan.
I mean, UX is important too. So I guess one thing I'm curious about, like from the side of like all the presentations today, is like, what are you guys outside of like? I mean, you're obviously you guys on the Aztec team and on Matter team are both really focused and interested in work that's happening on the ZK Snark side. But what else is really interesting to you guys in the ecosystem right now?
Actually, I've been seeing a resurgence of DAOs, and I have to say I absolutely love that resurgence. I mean, we've seen a couple of terrible things happen with DAOs, but also I still believe in the hope of them. So that's probably something I'm going to be diving into as a fun little side project in the future.
Oh, yeah, well, on my side, what we're interested in some final real world physical application when some assets which live completely on crypto or just systems which live completely on crypto can be used in a real life to solve real problems. I always say that for me, the ultimate goal would be to pay with Ethereum for a morning cup of coffee, and I'll drink a lot. So this would be the ultimate solution. A lot of things have to be done on this. Scaling, yes, it have to be there. Cheap transactions have to be there. Ideally, confidential transactions, which are also cheap and scalable, also should be there. But the most difficult part, how to satisfy all of these constraints.
I actually want to, if I can, just one last shout out. I don't know. We basically can't speak about it too much because it's like a slightly more traditional part of the company. But we're still doing some stuff on credit mint. So credit mint is like this loan issuance tools for loan issuers, and we're doing a lot of work on digitizing contracts for real world assets. And yeah, stay tuned. Basically, it's a really cool space. It'll take a while, but it's a really cool space to be exploring.
Awesome, that's really cool. We had one presentation request. So do you have something to share now? Actually, let's check the chat.
Sorry, before back out.
But yeah, if you're ready to present, feel free to give us a quick demo of what you're working on. Are you still there? So I don't know if he's around. Actually, he might have dropped off. But I guess one thing that I'm particularly excited about, which we talked about briefly last week. Oh yeah, sorry. There we are. Yep. Oh, next week. Okay. Yeah, for sure. One thing that I'm pretty excited about is, which we talked about last week, is the upcoming hard fork. So I'm kind of curious. It's a new set of guests. So what are everyone's thoughts about that? Any particular like pieces or I guess upgrades that you guys are most excited about?
Sorry about that. Two microphones turned on. I guess for us, we were super excited about the EIP for refundable storage within a transaction. I'm not entirely sure this. I actually, sorry, I've been kind of a bit of a stuck on a rock for the past couple of weeks. I'm not entirely sure how that was resolved. That's actually still going ahead. But if it is, we're super stoked because the cryptography engine takes advantage of that. And yeah, it was incredibly minor, but the bit shifting instructions help make our stuff marginally more efficient, which is nice. But yeah, I'm pretty stoked about the storage metering changes until it kind of blew up.
Yeah, I'm pretty sure the storage stuff is part of it because that's the problem with the reentrance because the fallback function wasn't getting burnt out. Like it was a cheap enough amount that the fallback function was actually able to call, and that's where the reentrance happened or something like that. To add to that, like I always show create too because I think it's like a cool UX trick to use to be able to like do counterfactual instantiation just a lot easier. I think we could basically do everything, but you had to do it with tricks. Where I think that just making it easier for developers, I think Create 2 is going to be a cool little thing that we can do.
Actually, yeah, that actually feeds into something to the kind of the legal morass we're getting into is trying to actually work with lawyers to construct legally enforceable smart contracts where people want something to sign ahead of time, and for that you need smart contract addresses that you're signing against with wet signatures, and so Create2 is incredibly useful for that because you can actually ahead of time can actually draft a legal document saying smart contract address at ABC whatever will do something even if you have to that smart contract can be created after that document is signed.
Yeah, one of the important parts for this create2 function, I think a lot of people wanted to have it for some kind of disaster recovery mechanism and cases when people just lose the private key for the address so they can do some recovery without the huge pain.
Interesting, like some kind of like a dead man switch that works off of like a counterfactual dead man switch or something, huh? I've never heard of that before.
Yeah,
That's cool.
Yeah, just with just a little bit smaller aspects, not just arbitrary counterfactual contracts, but yeah, actually it's a dead man switch or maybe even multiple ones. Like you can expose one or another.
Another thing we should be showing is ETH Denver. Everybody going to ETH Denver?
I will be there with bells on.
I mean, I'll be there for sure. But I think everyone should try and go. It was a really great event last year. I think this year it's supposed to be, although we talked about this before, that it might not actually get to quite that high number, but 3,000 people or so. So, I mean, that's pretty crazy.
I think maybe we need to have an event where Zach just writes assembly for us on a big screen. Just bangs out a bunch of assembly in a smart contract.
I mean, if you want Zach to come to events, the only thing, do you remember the Nick Johnson put on the gas golfing competition? We basically lost Zach for a full 3 weeks to optimizing like gas competition code. So yeah, just do that, but only in person, and he'll show up.
No,
Perfect.
I need to do meaningful work. But yeah, no, if you like that, you will love Huff. That's our domain-specific programming language we've written for writing EVM assembly. It is a horrible, evil language, but it is it's very efficient, and it's on our repository.
That gas competition was awesome. I ran the back end for it, so I was doing all the compiling and getting the numbers for everybody. So I got to see like some of the code come through. Yeah, it was good stuff. It was very educating for me.
Oh dear. Yeah. Oh god, I apologize.
No way, man. It's awesome.
Yeah. It was really fun. Yeah. So thanks for helping put that on. It was a lot of fun.
Awesome. So we've got like 2 minutes left. Are there any sort of final comments or questions? Cool. So with that, I just want to say thanks so much, everyone, for coming on and for presenting. And yeah, this is really exciting stuff. Again, I need to dive into it further. Oh wait, did I miss something in the chat? Okay, no. Yeah, and I'm excited to dive into it more on my end. Thanks again, guys, and we'll see you next week.
All right. Thanks you guys.
Thank you.
Thank you.
Very awesome job, guys. Look forward to me hounding you on Twitter.
Peace out.
All right. Bye bye.
Bye, guys.